Okay, so it looks like you found part 2 of writing these problems with a coefficient and a power. They'd like it in this format where you have the coefficient and then the variable to a power, but the variable's not in the denominator because they didn't write it in the denominator. Good? All right, so let's look at number 1. We're doing a couple of comparisons. We're looking at x over 4 versus 4 over x because sometimes the brain likes to play tricks. So here's something to consider. Let's look at the x over 4. Now, technically, if you notice, there's a 1 in front of this x. Is that agreed? So if I really wanted to, couldn't I write this as 1 over 4 times x over 1? So couldn't I write it as 1/4 x? So in this case, the coefficient would be 1 over 4. And the power here is technically a positive 1 on that x. Cool? Okay. Let's look at this one. 4 over x. Well, couldn't I write that as 4 over 1 times 1 over x because that x is in the denominator? Couldn't I split it apart like that? Okay, so then, couldn't this just be rewritten as 4 times x to the negative 1? Yeah, this kind of problem we kind of worked on in the first part of these examples. Very different. They are reciprocals of each other, but their answers are very different when it comes to the coefficient and the power we're working with. Got to look at them separately, take them as their own. How about number 2 over here? Let's look at this first part. This first part is basically 3 over 5 times x to the 4th over 1. Is it not? Because remember, multiplication lets me pull things separately, pull them apart. Are we okay with this? And so then couldn't it be rewritten as 3/5 times x to the 4th? So we have a coefficient of 3/5 with a positive 4 power on the x. Cool? This reciprocal, this is multiplication again down here, but couldn't I look at this as 5 over 3 times 1 over x to the 4th? And so we've seen how to make x to the 4th, how to rewrite it so it's not in the denominator. So wouldn't it be 5/3 times x to the negative 4? This coefficient is 5 over 3, and this has a power of negative 4. They're reciprocals of each other, but sometimes the brain likes to play tricks. So you really have to take them slowly and look at them individually. Cool? Okay, I have a couple more examples coming your way, so stay tuned. So how'd you do with these two? You're like, they're a little different. There's parentheses. That's okay. As I mentioned, take them slowly, take them one at a time to be able to compare them. So let's look at this first one. What did you do first? And if you're uncertain, what do you think I'm going to do first? I'm going to get rid of the parentheses. So I'm looking at the first fraction, and I'm noticing that the denominator is raised to the power of 3, which means, since this is multiplication in between there, that 3 applies to the 7 as well as the x, doesn't it? And there's still multiplication in between. Agreed? Okay, so what is 7 to the 3rd? No calculators. 343. Excellent. Times x to the power of 3. Now, we've seen this type of problem before. If they don't want that variable in the denominator, then how did you rewrite it? Good. The coefficient will be 3 over 343 times x to the negative 3rd power. Very good. Very good. How about this second fraction here on number 3? Okay, so there's no parentheses in the denominator, is there? So that power of 3 is just on the x. So technically, if you wanted to, couldn't you rewrite it as 2 separate fractions like this, like we've done before? By the way, some of you benefit from writing the little steps in, such as this one, and others of you are like, do I need to? You don't need to. but you know yourself better than I do. So I'm showing you the little steps in case you do need them. Okay, so this then is the coefficient of 3/7 times x to the negative 3. Be cautious. One had parentheses, one did not. The one with the parentheses, the power applied to everything in the parentheses. No parentheses, the power just applies to what it's sitting on, in this case, x. Let's look at number 2. Oops, sorry, I wrote number 2 incorrectly. Hold that thought. That 2 should be out here. Sorry. Okay, so let's look at the first fraction on number 4. See, I heard you guys. You're like, wait, if that was 3, how is it? You're right. You're right. This is number 4. Thank you for correcting me. See, this is why I need you guys to do the work with me. Okay. First thing you did on this first fraction for number 4 was got rid of the parentheses. Okay, so that is 8 over what? 9w squared. The 2 belongs to everything inside. Since there's multiplication, I can do that distribution. And then, yeah, it becomes like problems that we have seen a few times now. So is it okay if I went straight from 8 over 9w squared to 8/9 times w to the negative 2? Are you okay with that? And if you need this middle step for this problem, then do it. Cool? Okay. Whereas on this one, no parentheses in the denominator, which means this 2 only applies to the w. So we have, and if you want to write it separately, here it is. Agreed? Which means we have 8 over 3 times w to the negative 2 power. Cool? Excellent. You're getting better at this, understanding the difference between the two, because they're really similar. Good. I have 2 more coming your way, so stay tuned. All right, last 2. How'd you do? You did good? Okay, so tell me what you did on the first fraction for number 5. So you wrote it as negative 9. Yes, that is a 9, by the way. Over 16a squared. Very good. Remember, they want a coefficient and they want your power in the numerator. So negative 9 over 16, a to the negative 2. Very good, because that's how you bring the variable to the numerator, is the power becomes negative. How about this second half of this problem? You're like, well, that was just negative 9 over 4 times 1 over a squared. Some of you like to write it that way. Some of you don't. Some of you are like, I don't need to do that. That's fine. So negative 9 over 4 times a to the negative 2. Great. Again, you have to be cautious of what the exponent is sitting on. In this case, it's sitting on the parentheses, so it applies to both of them. In this case, it's sitting just on the a, so it just applies to the a. How about this first fraction? Negative 1 over 8a to the power of 3. Very good. Some of you wrote the middle step in. That's totally fine. But you still get this exact same answer as those who didn't write that middle step in. Yes? And this one? Aha! This one you're like, the 3 applies only to the a. So if you wanted to write it as 2 separate fractions multiplied together first, you can, but you still get this answer, don't you? Negative 1/2, a to the negative 3. Whereas the one with the parentheses is negative 1/8, a to the power of negative 3. Good? Okay, so is this making more sense, being cautious of what the power is sitting on? Is it sitting on parentheses or is it sitting directly on the variable? What's it sitting on? And how to rewrite them with the variable in the numerator? In most cases, if it's in the denominator, obviously it's going to have a negative exponent. But if it's already in the numerator, then yeah, you saved yourself a step of work. Cool? Okay, guys, have fun with it. Catch you on the flip side.